Hello students, good morning. Now today we will start our fourth chapter, that is acid, base and salt. Today I am going to explain this chapter. Already in our online classes we have done first two chapters, and this chapter I will explain in this video. First of all, what is acid? What is acid? So students, at your home you have lot of substances, materials. You have seen lot of materials and substances every day. For example, if you ask your mother to give us sugar, you also know about the salt. You very well known lemon juice or lemon. If I will ask you, how will you classify or how will you identify this is sugar, salt and lemon solution? Suppose I will give some powders to you and I told you that identify whether this is sugar, salt and lemon. So how will you identify? You will taste that material or you will taste that object. Okay. Suppose sugar. Sugar is sweet in taste. Salt is, salty in taste, and lemon, it is sour in taste. So depend on this taste, you classify your materials at home. So similarly, in our science also, millions of compounds are found up till now, and that's why it is necessary to classify the compounds of the chemicals. We classify the compounds as acid, base and salt. What is acid? Actually, acid, this word comes from word acidus. Acid word comes from the acidus and its meaning is sour. It is the fundamental property of the acid that whatever the materials they contain the acid, they are sour in taste. Okay. Now, in our lab also, some acids are available. For example, how will you identify? Suppose this is bottle, acetic acid. This is acetic acid. Another one, it is hydrochloric acid solution. In this bottle, this is sulfuric acid solution. So many acids are present in our lab, but not only in our science lab, but also at our home. There are acid, they are present at home. Okay. Now, sulfuric acid, which I have shown you in this bottle, this is sulfuric acid. So the formula of sulfuric acid is, this sulfuric acid is represented as H2SO4. Another acid, that is hydrochloric acid. Another acid, that is nitric acid. Okay, so these are the names of the acid. All these are acids and all acids are sour in taste. These are the acids which are available in our laboratory. Now acid, okay, these are the example of acid. These are few examples of acid. Lots of acids are there, but we come to know the name of this acid in our textbook. Okay. Now students, these are the acids which are present in our lab, but not only in our science lab, but in our everyday life there are so many food items which contains the acid, and because of that acid, that food becomes sour in taste. For example, some of the common use acids, this written in the blackboard, and from where it comes. For example, first acid is acetic acid. First acid is acetic acid. Now commonly at home, we call this acetic acid as vinegar. We call it as vinegar, and you all know that Chinese food items are especially use this vinegar. Now where this citric acid is present, juice like orange juice, fruits, lemon, these fruits they contain the citric acid. Tartaric acid. Tartaric acid is present in tamarind, grape, Tamarind is a big source of this tartaric acid. Lactic acid is present in curd. You know it, it is very common at your home. Okay. Malic acid, it is present in apple. Oxalic acid is present in tomatoes. Amino acid is present in protein. This tannic acid is present in tea. And carbonic acid is present in your cold drink. By looking this acid examples, you can confirm that at our home also, every day, daily, we use so many acid, different types of acid. Now, we will come towards the properties of acid. What are the general properties of acid? You know, I told you first time that acid is sour in taste. So, first property is it is sour in taste. Second, it is very corrosive. If we use the acid like this, sulfuric acid, like this hydrochloric acid, so these acids are very strong, they are very corrosive in nature. Third, this acid converts blue litmus paper red color. Blue litmus paper red color. Now what is litmus paper? I am going to show you the litmus paper. It is available in our lab. All these are the litmus paper. Okay, all these are the litmus paper. You can see that this litmus paper strips, it is of blue in color. Okay, so not only blue color but two types of litmus paper is available in our lab. That colors are red color and blue color. So, if we want to identify which is acid and base, so it is a laboratory test. So, while doing the testing, we use this litmus paper. So, if we do the practical or experiment of acid, in this acid, this blue litmus paper is converted into red litmus paper. Okay. Another property is these acids are colorless. Acids are colorless. They are having a pungent smell. Acid contains any acid. For example, I have given you the examples of hydrochloric acid, sulfuric acid, nitrochloric acid. If you observe these formulas carefully, then you will notice that every formula contains this hydrogen. This means acid contains hydrogen. This means acid contains hydrogen. Now I have written hydrogen as with positive ions. Okay, hydrogen with positive ions. So what are these ions? These are the compounds. These are the compounds which are present in the chemicals. For example, if you know the formula of water, then this water is made up of hydrogen and hydroxyl ion. So we have to represent the ion as positive ion and negative ion. So all the acid, they contain hydrogen. That's why we represent the acid as hydrogen plus ions. Okay. The most useful purpose of this acid, which I am going to explain and which is given in your book also, that is a soda acid fire extinguisher. You might have seen the red colored cylindrical bottle is present in our school building also. In every school building, hospitals, cinema theatres, everywhere it is essential to keep a fire extinguisher cylinder. Okay. Today I am going to explain a soda acid fire extinguisher. It is a portable fire extinguisher. How does it works? How this fire extinguisher works? Students, in this diagram, at the bottom of this bottle, there is present a solution of sodium carbonate solution. Okay, the formula of that sodium carbonate is Na2CO3. This is sodium, this is carbonate. In another small bottle is present, a glass bottle is present. Inside this big bottle, a small bottle is present, and that glass bottle contains sulfuric acid. It also contains the sulfuric acid. So what happens when we press this knob? The head of this small bottle, it touches the bottom of this bottle and it gets breakdown. So after breaking this small bottle, what happened? The solution of this sulfuric acid is come in contact with this sodium carbonate solution. When sodium carbonate solution come in contact with this sulfuric acid, it produces sodium sulfate plus carbon dioxide gas plus water. This is sodium sulfate plus carbon dioxide gas and water. And you all know that oxygen gas is a combustible gas. It helps in or it support in process of burning, but carbon dioxide is non-combustible gas and it does not support in burning. Okay, so this principle we are going to use in this fire extinguisher, because this carbon dioxide gas does not help in burning. Carbon dioxide gas जो है does not help in burning. So that's why after as the both solution get mixed, carbon dioxide gas evolve from this nozzle. It comes out from this nozzle and it spray out through the surrounding to extinguish the fire. In this way, this soda acid fire extinguisher works with the help of this carbon dioxide, which does not support in burning process. Okay, students, what are bases? Bases are the hydroxides or oxides of metals. Bases are hydroxide and oxides of metals. Okay, these bases are soapy in touch and bitter in taste. As we know that our acid is sour in taste, these bases are bitter in taste. Comparison to acid, these bases are less soluble in water and acids are more soluble in water. So some of the bases, they are sparingly soluble in water. Which are they? For example, sodium hydroxide. This is sodium hydroxide. Another example, potassium hydroxide. Third example, calcium hydroxide. These are the only few examples of the bases which are soluble in water. This means the bases which are soluble in water, they are sodium hydroxide, potassium hydroxide and calcium hydroxide, and all together they are called as alkalis. Don't get confused in bases and alkalis. Okay, bases are different and alkalis are also different, because all bases are not soluble in water. Only few of the bases, they are soluble in water. That's why they are called as alkali. So we can infer or we can conclude that all bases are not alkalis, but all alkalis are bases. All alkalis are bases. I told you that in acid we use a litmus paper. For performing the acid test we will use this litmus paper. Okay, so I told you that in acid what happened, blue litmus is converted into, in acid blue litmus paper is converted into red litmus paper. Just opposite to this, in this base, this red litmus paper is converted into blue color. Okay, red color is converted into blue color. It is highly soluble in water, it is less soluble in water. It is also colorless, these bases are also colorless. You might have seen that at home also, when you suffer from the acidity, if you get any time the problem of acidity, so you have to use the medicine. Which the medicine contains? The medicine contains the base. The medicine contains the base to neutralize the acid. If you suffer from the acidity, you have to take the antacids, which are having the properties different from the acid. एसिड के अपोजिट जो प्रॉपर्टी होती है, दैट इज यूजिंग इन दिस एंटासिड. सो स्पेशली दिस एंटासिड कंटेन्स मैग्नीशियम हाइड्रोक्साइड. इट इज प्रेजेंट इन द फॉर्म ऑफ जेल. So while taking the medicine of the acidity, actually what we are using? We are using the base. Okay. What are the examples of bases? You all know potassium hydroxide, sodium hydroxide, calcium hydroxide, aluminium hydroxide. So many examples is given in your book also. All these are the hydroxides or oxides of metals. Aluminium is a metal, you know, sodium is a metal, potassium is a metal. Okay, this means after looking all these formulas, again one thing is observable here, one thing is clear here, that all the formulas they contain the OH ions. All the formula they contain the OH ions. This means in acid, all the formula they contain the H plus ion, and in all the base, the formulas contains the OH minus ion, that is the hydroxyl ion, and it is the hydrogen ion. So this is the fundamental property of the base, that it contains the hydroxyl ion. Okay. Now you all know that these are the laboratory chemicals which are the acid. Okay. This is potassium hydroxide palette, which is basic in nature, so this is a base. So students, when these acid come in contact with base, so what will happen? Okay, suppose you have acid and it comes in contact with base, so it produces salt and water. What will happen if this acid is come in contact with this base? So there is production of salt and water. This whole reaction is called as neutralization reaction. This whole reaction is called as neutralization reaction. Okay. Now suppose, for example, we have one acid present, that is hydrochloric acid, HCl. This is hydrochloric acid. Hydrochloric acid plus, we take any of the base, for example, I am taking NaOH, that is sodium hydroxide. It will give you salt and water. So NaCl, that is sodium chloride. Its common name is salt. Every day we are using this sodium chloride at our home. plus water. This is the formula of water. So this is neutralization reaction, in which acid and base both they react with each other and they form a new product, that is salt and water. Okay. Now we will perform two activities. One activity is given in your page number 59. In your textbook, page number 59, activity is given. Okay. So first I will show you how we come to conclusion that acid is present. Okay. In my acid topic, I told you that some acid is present in your soda or cold drink. Okay, so at your home you use the Eno, soda, etc., etc. So in our lab also we can perform this, and I will show you how the effervescence will come. Okay, now this is baking powder. Actually this is the chemical name, this baking soda, it's a common name, but its chemical name is sodium bicarbonate. This is sodium bicarbonate, and commonly at our home we called it as baking soda or baking powder. Okay, now we can do, take into a test tube small amount of this soda, vinegar. I told you that acid, citric acid or vinegar, which is present at our home also. So this is citric, this is vinegar. I am going to add, look at carefully this test tube. Okay, you have seen the effervescence, it is clear to you. So the evolution of these bubbles which are present as a effervescence, students, which effervescence you seen here, that effervescence is nothing but it is the evolution of the gas, that is carbon dioxide, and this shows you, this is the proof that this soda contains, this sodium bicarbonate contains the carbon dioxide. Okay, now second activity which will perform, it is very interesting activity. What we will do, first we will discuss about the indicators. Okay, I will explain just now that I have explained just now that this is the vinegar which I used. So what is the chemical formula of vinegar? It is our acetic acid. It is our acetic acid. See this bottle, name is also written here, it is acetic acid. Okay, the formula of this acetic acid is CH3COOH. What I add into this powder, that is sodium bicarbonate powder. So as I told you, in neutralization reaction, if any acid it come in contact with, it form the salt and water. So what it will form? It will form CH3COON, that is it is a sodium acetate salt, plus evolution of carbon dioxide. You have already seen in this test tube, we have seen the evolution of carbon dioxide, and it is a gas plus water. So students, this is one of the example of neutralization reaction. Okay, our last topic is indicator. What is indicator? Actually, while performing the experiment, any of the experiment, if there is color change, that color change need to explain whether the substance is acid or base. If we want to classify acid or base, so what we will do? We will see the colors. We will see the colors, whether it is acid or it will be base. So again, second activity is given in your book, which depend on the color. For that we will use the turmeric powder. Okay, For that we will use a turmeric powder. Now there are two types of indicators, students. Number one, this turmeric powder, you all are looking that this powder is yellow in color. Okay, the color of this powder is yellow color. So as I am using this natural indicator, this haldi powder or this turmeric powder, it's our natural indicator. Natural indicator. First, I will make a solution of this natural indicator. So, I make a solution of this natural indicator. Okay. Spatula is not available, so I am using this spoon. You all can observe that this solution is of yellow color. Which color? Yellow color. Now, this natural indicator, in this natural indicator, I will add a detergent powder. Okay? I am having this detergent powder. So, chemically this detergent powder is nothing but it is the sodium carbonate which is available at our home. Commonly it is known as detergent powder. This is sodium carbonate. So I am going to add this sodium carbonate into this natural indicator, that is your turmeric. See the change in color, students. So this yellow color, it changes into dark red color. Okay, yellow color is changes into red color. Again, what we will do? Now we add some acid into it. Okay, so at present I have this lemon juice, and you all know that this is acidic in taste, sour in taste. So when I add this lemon juice into this, what happens? What you notice? That again the color is going to change and it is converted into yellow color. Okay, so this is what the change in color, this change in color is the indicator. This indicator shows whether the given substance, okay, now these powders are available here. How will you identify that these powders are acid or base? So we can easily judge by using this natural indicator, or as well as in our science lab another indicator, that is artificial indicator, is also available in our lab. In our book also some examples are given, like phenolphthalein, methyl orange indicators. These are the indicators which shows the color change. Okay, so students, similarly like this detergent powder, I have this salt also. This is called as common salt. This sugar also, baking powder, all these are the natural products which are present at our home, and by using this natural product we can infer or we can conclude that whether the substance is acidic or basic in nature. Similarly, you clearly know what about how to know the indicators. Indicators are nothing but they are the color changes substances. They are the chemicals which changes the color when they come in contact with acid, or if they come in contact with base, their color changes. Okay, thank you, students.